substance for now. So we continue with the last time discussion. آخر مرة كان الكلام عن we started chapter 4, right? Which was basically about multiple random variables. And we said that multiple random variables are in many situations where we need to describe certain phenomena using more than one variable. And we gave the example with us. So, and then we started talking about, okay, how to explain, how to mathematically explain these two variables. We said that, okay, we have the joint distribution and the joint density function. Joint it's basically the, if you define an event A, which is the first random variable being less than a specific number, B, another event B, which is the other random variable being less than a specific number, then we can define the probability of these two events, the intersection between them, which is the probability of x less than specific x, y less than specific y. Then the commutative distribution function will be defined as f xy, where xy here represents the two random variables, x and y, evaluated at specific numbers, small x, small y, which is defined as the probability that x is this time or equal to specific x, and at the same time y is this time specific y. And then we talked about how do we basically, we listed these two events A and B in two dimensions, x and y, and where the intersection, we said that the intersection is basically where basically the two values x is this than x to the left of this point, and y is this than y to the bottom or below this. And then we gave several examples, specifically discrete examples. We went through the details of how to see the probability distribution in the two-dimensional space, and how to find the fxy at different locations. And we went through this by first of all finding the events corresponding to fx or whatever these numbers. What are the corresponding events? X less than specific 0, and for example, and y less than or equal to. And then we find the corresponding event x and y. And then we find the probability of the intersection between these two events. And almost we stopped here at the properties of the joint commutative distribution function. First of all, these are the properties. So basically, first of all, fxy evaluated at minus infinity and at minus infinity. So when x equal minus infinity and y equal minus infinity, what is that? 0, because this is equal to the probability that x is less than or equal minus infinity and y less than or equal minus infinity, which is both of them is impossible, right? So because of that, this is 0. Now, if one of them is minus infinity, so the probability that, so if xy at minus infinity, x minus infinity, and any one, what would be this equal to? Why? Because this is again the intersection of the probability of x less than minus infinity and y less than specific number. Then one of them is impossible, so basically the intersection between phi and anything is phi. So basically this is, for example, the probability that x less than or equal minus infinity and y less than or equal 1. The intersection between them is phi. So this is the probability of phi intersect y less than or equal 1, which is equal to 0. Okay. Similarly, if fxy at any x and y equals minus infinity. Similar. So basically, when we put minus infinity at any of one of them, we get 0 because there will be a phi in that component with x or y, which will have the intersection between the two events, the phi, which will give you the probability equals 0. On the other hand, if we write fxy at infinity and infinity, so this is basically what equals the probability of what? X less than infinity and y less than, and we know that both of them are always the same. So this is basically the certain events. And this makes basically the joint CDF between 0 and 1. It cannot exceed 1 because at the maximum it goes to 1. and at minimum it is 0. And this is goes without saying because this is a probability function by definition. Now, also fxy of xy is non-decreasing function in both x and y. So if I fix y and increase x, it either increases or stays the same. Because fixing y and increasing x means that I'm including more events in x, right? Which will either increase the probability or keep it the same. Similarly, if I fix x and I increase y, I am including more events, right? And hence either the probability will increase or stay the same. Of course, if I increase both at the same time, again, either I'm including more events, so either probability will increase or will stay the same. However, increasing x or y or both will never have reducing, we will never have a smaller value for this function, because increasing x and y means including more events, which will increase or the probability or stay the same. Okay. Now, if I want to find the probability that x lies between two numbers, x1 and x2, and y lies between two numbers, y1 and y2. Remember, when we had one random variable only, how did we find this probability? Fx at x2 minus fx at x2. Right? Here we have x and y, so the answer will be, it will be basically easier to show in this picture. So basically think about it this way. I am interested in finding the probability that x, so fx y at x2, so this is fxy x2, y2, right? So at x2 and y, I'm interested in what? Finding the probability that x is between x2 and x1, y between y2 and y1, right? So I'm interested in finding the probability that x is in this range between x1 and x2, and y at this range between y1 and y2. So I'm interested in finding the probability of this region, right? هذا اللي أبغاه. أبغى the probability that x lies between x1 and x2, and at the same time y lies between y1 and y2. This is the region of interest to me in the two-dimensional plane. So the way we find it is, first of all, we write that this is equal to the fx, y, x2, and y2, right? هذه عبارة عن ايش شباب؟ This is equal to the probability that x is this than x2 and y is this than y2. Right? So this includes everything. This includes everything here and everything here. يعني تحت. صح. This includes well. هذه includes everything to the left of x2, right? And everything below y2, صح؟ كل شيء تحت، كل شيء هنا. Okay? However, I am not interested in this. I'm interested only in this square. صح؟ So I need to subtract أول شيء هذا صح ولا لا؟ هذه الجزئية تعطيني كل المربع الكبير طبعا إلى minus infinity x and y. I'm interested in only this. So I need to subtract first of all, I need to subtract minus h y. هذا صح؟ fxy at x1 and y1. صح؟ ايش حيصير؟ ايش حيبقى؟ أول واحد عبارة عن كل شيء. صح؟ الأصفر عبارة عن هذا. and y less than 1. طيب؟ راح ايش؟ راح هذا بس. باقي هذول الاثنين موجودين. So what do I do? تمام معايا؟ So I subtract what كمان؟ fx y at what? At x1 and y1. y2 sorry. هذه الجزئية. if I subtract this, what I'm subtracting? I'm subtracting هذا كله. X1 and Y2. So X1 and Y2. I'm subtracting all this. I will subtract also X2 and Y1. هذا هو الجزئية هذه. Y1 هذه الجزئية كاملة. طيب what did I do here? I subtracted هذا وهذا وإيش كمان؟ هذا مرتين. صح؟ ليش؟ لأن I subtracted it. Sorry ثلاث مرات. I was a mistake. There was a mistake here. المفروض إني I didn't subtract this. sorry يا شباب. هذا عبارة عن المربع هذا عبارة عن أنا أبغى كل هذا فأنا أبغى هذا بس. فبasically I subtract from it this one or this one. Now in this case I'm subtracting this twice, so I need to add it here. I need to add it as, because I subtracted it twice, I need to add it once. So it will be fx x2 at y2 minus fx x1 y2 minus fx y x2 y1 plus okay. الجزء اللي طرحناه مرتين اللي هو هذا بس. Okay, so basically this is the answer here. You find that this is equal to fx 2y2 minus ايش كان لونه هناك؟ الأخضر at x1 y2 x2 y1 and then adding it to it الجزء اللي طرحناه مرتين and there is a plus here. Now, now if I put infinity at one of them, if I put infinity here, what is fx, y at any x and y equal infinity? What is this equal to? fx, y at x, any x, however infinity at y. What is this equal to? Yeah, اعطونا يلا. What is this equal to? دائما نرجع للديفينيشن عشان ما نلخبط. ماشي شباب. This than or equal x, yeah, and what? Y this than or equal infinity. How do we know that? What is this? This is كأنك أنت جالس تقول هذا probability of x this than or equal x intersect ايش؟ The sample space. I know that. This is because x less than y less than or equal infinity. This is the sample space. So if this event intersect with sample space is what? Is the probability of x less than or equal x, which is the CDF of x at x. واضح شباب؟ سويناه هنا. So if xy, when I place y at infinity, when we derive it, basically this is equal to the probability that x is less than or equal specific x, which is equal to the CDF of x. So placing y equal infinity as if y didn't exist. Then I'm not taking y into consideration. All this boils down to what is happening in x. Similarly, if I put infinity at the x location, so if xy, where x is equal to infinity and y any number, then with similar thing, this will be the probability that y x less than infinity and y less than specific number, which is y less than specific number, which is fy. وهذا يسميناه ايش شباب؟ marginal distribution. ليش marginal? Because we marginalize y here. We marginalize sorry y here. We marginalize means همشناها كأنها مش موجودة. And here we marginalized x, and we get the marginal. So basically, when I put infinity at y, I get the marginal distribution of x. When I put infinity at x, I get the marginal distribution. All right. Similarly, now, if you have 4 random values, for example, if you put infinity at 2, you get rid of them. So if I put infinity at y and z, I only get the joint PDF of X and if I put infinity at Y and W, I get only this, the joint CDF of X and Z. That's all. واضح الفكرة؟ So this is why this is the case. طيب خلينا هذا شرحناه already. ناخذ example. Let's talk mainly about the marginal distribution. تكلمنا عن الموضوع الماضي and we calculated it. However, let's have some more examples. So here we have, I'm giving you this joint distribution. So basically, the probability that x equal 1 and y equal 1 is 0.2. تكلمنا عن نفس الإكزامبل اللي في الماضي. X equal 2 and y equal 1 is 0.3. X equal 3 and y equal 3 is 0.5. And we want to find what is, and we can write the joint CDF as 0.2 step function at x equal 1 multiplied by step function at y equal 1. Right? Yeah. Plus, now the next step, 0.3 multiplied by h, step function at x equal 2 and step function at y equal 1. So think about it as this. This CDF is equal to 0 before for numbers x less than 1 and y less than 1, right? Let's show probability that x less than 0. 0, right? I'm giving you this is the distribution of the two random variables. So what is the probability that x is less than 0 and y less than 0? It cannot happen, 0. So this function, the joint CDF, stays 0 for all numbers in x and y have الآن هنا x and هنا y. For all numbers in x and y less than 0 and less than what is now? X equal 1 until x equal 1 and y equal 1, this is all 0. Not here. Now when we reach to x equal 1 and y equal 1, what is the probability that we add here? 0.2. So there will be a step function, a two-dimensional step function in x and in y with a magnitude of 0.2. So this is the magnitude, 0.2, multiplied by a step function in the x direction at 1 and step function in the y direction at 2. Now between x equal 1 and x equal 2 and y equal, doesn't matter, y equal 1, what is the value of this probability? So basically, if I, between here and any point between x equal 1 and 2, the same probability stays. Then when we ask yourself, what is the probability that x is less than or equal 1.5 and y less than or equal 1.5? It's the same, 0.2. It stays the same until we reach x equal 2, where there is a new probability of 0.3. So this is another step function at x equal 1, x equal 2, right? Right? And then it stays the same until we reach x equal 3 and y equal 3, where we have a 0.5. In this case, there will be another step function of 0.5 magnitude x and y, which is step function x, y, x equal 3 and y equal 3. Okay. Now, if I want the marginal, what does the marginal say? Marginal is when I'm interested only in how the distribution changes with the values of x. My y can I see here? What are the values for x? 1, 2, and 3, right? Doesn't matter what y is. When does the value of x happen? Change to 1. So, sorry, when does the function here, fx of x, change from 0 to anything? Before 1, it's 0, so at 1, it starts to have something. اللي هو 0.2. Right? And it stays 0.2 until we reach what? X equal 2. It becomes 0.2 plus 0.3, which is 0.5, and so on. So basically, you can think about it this way, or you can think about it as this is equal to the joint PDF, so the CDF, with y equal infinity. What does y equal infinity? If you put y equal infinity here, what is the step function? What is the value of the step function at y equal infinity? 1, right? So كان هذه كانت مش موجودة. What is the step function at y equal infinity? 1 again, right? So هذه تصير كانها مش موجودة. وهذه تصير كانها مش موجودة. فايش يصير عندك؟ 0.2 ux minus 1 plus 0.3 ux minus 2 plus 0.5 ux minus 3. Because when y equal infinity, all these step functions, we know the value is 1, right? And hence this is the requirement here. The first one, the second one, the third. And for x, fx of x. Now let's see fx of y as well. Fx of y, think about it both ways. When we put infinity and when we think about it from the distribution point of view. Let's put infinity in x. When you put ux, u infinity minus 1, what is the value of this? It's 1. So what do you get? 0.2 u of y minus 1. When you put infinity in x here, what do you get? The step function is 1. So it's 0.3 u of y minus 1 again. And when you put infinity here, you get 0.5 u minus 3 u y minus 3. So what do you think? What do you see here? You see here two step functions at the same location, 1 and 1. You add them. What do you get? 0.5 u of at 1 plus 0.5 u at 3. Now let's go and see the probability distribution. Now I'm interested in y. Forget about x. Before y equal 1, what is the value of fy of y? 0, because y cannot take any value less than 1. Now when I start and I reach 1, what is the probability that y is less than or equal to 1? Which is fy of y. 0.5, because we have here y equal 1 and y equal 1. We add them together. I'm marginalizing x. Just hamish x. Okay? So what is the value of fy of y equal with y of 1? 0.5. And it stays 0.5 until I reach y equal 3. It becomes another 0.5 at step function at y equal 3. So think about it from mathematics, just plugging infinity, or think about it from the distribution when you just ignore x or ignore y. Well, so both ideas should give you the same answer at the end. Okay. Now, if we want to plot the CDF of x, so this is the CDF of x. CDF of x, it's basically CDF of x, right? You have 3 and you have 1. So this is 1. معلش في لخبطه في الارقام. This is 2 and this is 3. هذا الارقام في النص. 0.4 and so this is 1, this is 2, this is 3. الارقام في النص. So now fx of x, if you look at it, it's a step function at x equal 1 with 0.2 حتى الارقام هنا. And then another step function at x equals 10. 2 with another 0.3, and the third step function at 3 with 0.5. Now, how do you see this? If you look at the x-axis direction, كأنك أنت just تشوف the x-axis, you are not seeing the y. You see here, there is a step function at 1, another step function at 2, a third step function at 3. As if you are looking from Java. Now, in the y direction, this is 1 and this is 3. There's a step function at 1, which is 0.5, صح? And another step function at 3 with 0.5. Now, think about that you are looking at from y point of view, from y perspective. What do you see? You see a step function بيرة 0.2 زائد 0.3. انت بالنسبة ل y, when you look at from this direction, you will not see these details. الجنب هذه صح? هتشوف كأنها درجة كبيرة عندك equal 0.5 and another one equal 0. Any question? في dimension ولا؟ كيف؟
هذا حيكون يعني ممتد.
هذا؟ إيه يعني شوف أنت هذا هنا الوين كأنها ستيب كبيرة. يعني this basically هذه at 1 which is 0.2 كميتها يعني ارتفاع الدرجة هذه 0.2 في درجة ثانية at y at x equal to again of 0.3 هذه هي شكلها. Now أنت لما تطلع من الواي direction إيش حتشوف؟ حتشوف كأنها درجة واحدة 0.5 بالنسبة للواي direction. When you look at it from here you will not see the details إيش صار عند الإكس. أنت بالنسبة لك من الواي direction حتشوف درجة واحدة 0.5. You don't see the details. الديتيلز هذه تبين وين؟ look at the x direction. زي كأنه عندك درج تشوفه من اليمين أو تشوفه من اليسار.
ما تقدر تشوف ال 0.3
من الواي direction ما حتشوف ال 0.3. تشوف كأنها درجة واحدة لون واحد. هي في ديتيلز أنت ما تشوفه. لما تشوف من مسقط الإكس تشوف التفاصيل. أنا ما أقول الدرجة مش موجودة.
لأن الواي
خلينا نقول أنت عندك درج نفس البلاطة. يعني البلاطة اللي فوق البلاطة هذه نفس البلاطة دي نفس البلاطة دي نفس البلاطة. أنت when you look at دائرة الدرج إيش تشوف؟ شوف شيء واحد، شوف كأنه زكلية صحيح. ما حيبين عندك تفاصيل. فأنت الآن think about it as these two steps. هتشوفها كأنها بالنسبة لك it's one thing. لأنه أنت ما أنت شايف إيش التفاصيل اللي هي تخلي الإكس الدرجة هذه مختلفة عن الدرجة هذه. فاهمين إيش قصدي شوي في الأشياء المعمارية لما تسوي ديزاين درج نفس الدرج كله كذا ستريت هذا نفس هذا نفس هذا إيش حيطلع لك؟ كأنه زكلية. ما يبين أي شيء، ما في أي تفاصيل. التفاصيل ما تبين لما تشوف الدرج من هنا تلاقي داور في سليبس. نفس الشيء هنا يبين لك كأنها درجة طويلة مرتفعة لكن الإكس هي تبين لك التفاصيل واضح؟ بينما في الواي يبين إنه هذه الدرجة مختلفة عن هذه ليش؟ لأنها شفتي كأنها صار درجة كده هنا ودرجة ثانية كده هنا لأن في الواي يبين إنه الأرض هنا. Anyway شباب لو غير شوية imagination think about it and try to do it.
الانتراج وصلت إلى الانفينيتي دي 1
إيه من 3 إلى infinity في both directions هيكون 1 خلاص. إيه الرسمة هي الرسمة 3 dimensional صعبة بس try to imagine.
الرسمة هذه مش توضيحية يعني ما تحتاج نفس الشيء.
لا أنت ما تحتاج ترسم زيها بس you need to understand الفكرة. إذا فهمت الفكرة يعني الرسم ما هو مطلوب منك إنك ترسم 2 dimension 3 dimension بس لازم تعرف تسوي الأشياء هذه سهلة. بس you need to understand how does it look like how do you understand التوزيع الأرضي اسمها. طيب again نفس الفكرة هنا الآن جالسين نتكلم عن نفس الإكزامبل. الآن if you differentiate the steps هذه هذه step function what do you get? In the x-axis you get 2 deltas صح؟ دلتا هنا ودلتا هنا بينما في الواي axis you get دلتا هنا ودلتا هنا. So if you differentiate this in 2 dimensions you will get 3 deltas. One at 0.2 هذه أول واحدة. One at 1 and 1. One at 2 and 1 also of 0.3 and one at 3 and 3 هذه الأخرى. هذا هو التشينج so the probability distribution. What is the probability distribution زي ما قلنا الأول أو density the probability of total one how is it distributed among the different values. So now this tells you how is this total probability of 1 distributed among the different values of x and 1 وين مركزة وين مش مركزة. الآن if I want to find so basically this from here to here you need to what differentiate respect to x and y in order to get from here to here. تمام. If continuous random variable this will not be deltas it will look like a surface شكله كده كأنه بارابوليك مرات ممكن يكون مرات كأنه بيل شيب وتبقى يعتمد على شكل السيل. إذا جاوسون حيصير كأنه بيل شيب كأنه جرس. إذا ما هو جاوسون حيكون شكله وتبقى. So it will be a surface. Here it will be impulses. When you have continuous, it will be a surface. Surface. Now, so basically, هذه نفس الكلام
السيرفيس هذا الحجم حق بالنسبه للسيرفيس يعطينا
an area under the curve of this surface, the area under this surface, if you integrate in 2 dimensions under the surface, it will give you one. Okay? So if continuous non-variable, this will be a smooth surface, and the area under it will be 1. الآن هنا هذا ايش يعطيك؟ كيف السيرفيس؟ كيف تقرأ السيرفيس هذا؟ seems very clear من السيرفيس، لسه ما تكلمنا عنها بتفاصيل، لكن seems انه معظم القوانين مركزه وين؟ مركزه مثلا بين x equal 0 و 5 صح؟ This is the largest. وبين y equal خلينا نقول 5 و minus 5 right؟ الباقي تقريبا 0 تقريبا، يعني شوف كيف بعد ال 5 almost تصير صغيره، قبل ال 0 almost صغيره في الاكس اكسس، في الواي اكسس less than 5 larger than 5 becomes almost 0, less than minus 5 becomes almost 0 والباقي مركز في النص كده. يعني هذا يعطيك visualization of how is this total probability distributed among the different values of x and y. زي اللي اتكلمنا عنه في ال 1 dimension هنا 3 dimension. Again, you don't need to plot these things, but you need to understand their meaning. ايش معناها؟ الآن هذا يودينا على الجوينت density and the properties حق الجوينت density. نحن قلنا إنه if you differentiate this joint CDF twice, once with respect to x, once with respect to y, you get the joint PDF. What does the joint PDF? It's double derivative of the CDF with respect to the joint CDF with respect to x and y. ما تفرق تبدا x تبدا y doesn't matter. طبعا اول شيء you are differentiating a non-decreasing function. احنا قلنا هذا non-decreasing. It's positive. It's non-decreasing. So non-decreasing when you differentiate it, you get what? Positive function. So this is because fxy of x and y is non-decreasing. Right? And if you integrate, if you sum the area under the curve, you get then you have density. It gives you the distribution of the one among the different values. So if you sum over all the values x and y, you get the total polygon. And if you want, because this is the derivative, if you now want the value of the CDF at x and y, you need to integrate the PDF from minus infinity to y and from minus infinity to x. So these are the values that you integrate for. Whatever you put here, you need to integrate here. واضح شباب؟ Whatever the value here, you need to integrate in x and y. And if you want to find the marginal CDF of fx only, ايش كانت المارجنال CDF؟ لو تتذكر. How did we write it? This was the كم كانت infinity وين كانت؟ x and infinity at the y, right? So if I put infinity at the y, if I integrate infinity at the y, what do I get here? The CDF of x. So if I integrate in y, so the whole y disappears, as if y doesn't exist. كله هذا يختفي. Then I'm integrating over all the y. So what do I get? I'm getting the integral from minus infinity to x of the PDF of x. خلاص y اختفت. I marginalize it. So what do I get? I am getting yes, I'm getting the derivative, sorry, the integral up to x of the PDF, and I'm integrating over all the values of y. And similarly, if I want the marginal of y, I'm integrating with respect up to y, and I'm integrating with respect to x for all the values. So x here, هذا الانتجرال حق الاكس، بينما هذا الانتجرال حق الواي. لاحظوا هنا. I'm integrating infinity to infinity y, بينما integrating here minus infinity to infinity x. What? Now, let me ask you this. If I differentiate this, what do I get? If I differentiate this, what do I get? The PDF of x, right? Now if I differentiate this, what do I get? With respect to x, what do I get? هذا هيختفي الانتجرال صح؟ So now let's see. F x of x, which is the derivative of x of x dx, right? Now from here, this integral disappears. So what do I get? I am getting integral from minus infinity to infinity of f xy of x, right? And y. dy what is that? dy. Okay. When you integrate, so basically in order to find the PDF of x, you simply integrate the joint PDF with respect to y. But if you want to find the PDF, the marginal PDF of y, what do I get? I integrate the PDF of the joint PDF, but with respect to what? Yeah. So if I have the joint density, I can get the marginal density by integrating with respect to the other line. هذه نفس الفكرة حقت التوتال probability لو تتذكر. نفس فكرة التوتال probability. طيب خلينا نمشي على أول بعدين ممكن نرجع لكم. Yeah. So now this is basically the concept that I was talking about, marginal density. Derivation here. Why do we get this? Because of this. When I differentiate this with respect to x, the whole integral الانتجرال اللي برا يختفي يصير only one integral with respect to y, which I get this. Okay. Now, if I want to find the probability between that x between two values and y between two values, then I double integrate the PDF over these two values in x and y. So for y, I integrate between y1 and y2. For x, I integrate between x1 and x2. Let's have an example. Now, the example here we have, first of all, I'm giving you the PDF, the joint PDF, which is given of x and y, which is b e to minus x cosine y. It's a PDF, not nice. Okay, for certain values of x and certain values of y. So this is the PDF. Now the question is find the value of b such that this is a valid joint PDF. Now what do we need to do in order to find the value of b? I'm giving you a joint PDF. We can find the value of b such that this is a valid PDF. What do we need to do to find that this is a valid PDF? The joint PDF should integrate to one, right? So simply I need to integrate the PDF for x and y from minus infinity to infinity, minus infinity to infinity, and this should sum to 1. Whatever that gives me, I need to equate it to 1. So if I integrate, this is the joint PDF. I integrate it with respect to the value of x. X is between 0 and 2, and y is between 0 and pi over 2. Now you have an exponential multiplied by cosine. You need to do it by, luckily you can separate it, right? There's no, basically they are disintegrating. The x integral is alone, while y integral is alone. They are different. And exponential integrates into exponential, and the cosine integrates into minus sign. And when you substitute, you get this. Now you need to equate this to 1. When you equate it to 1, you get b equals to this. Okay, this ensures that the joint PDF sums to 1. That's good. Now another question, find the marginal densities. Marginal is what? For x is fx of x. For y, it's fy of y. In order to find fx of x, I need to integrate with respect to y. From minus infinity to infinity. This is for x. بينما for y, I need to integrate with respect to h to x. So I integrate with respect to x. So I always, in order to find the marginal for x, I integrate with respect to y and vice versa. So if I integrate with respect to y here, what do I have? I have e to minus x, b e to minus x cosine y dy. b e to minus x is irrelevant, so you can get it outside. So you have cosine y, right? Cosine y between 0 and pi over 2, which gives you basically 1, and you get basically this. So this is the PDF of x. ايش شكلها هذه؟ ايش رايكم؟ What kind of margin variable is this? X is x. Okay. And you can go and check whether this adds up to 1 or not. Check it out. Check f integrates f minus infinity to infinity fx of x equals 1 or not. Check it. Try it should. لأن كل شيء بدأ صح المفروض إنه should. Now let's see fy of y. Fy of y you integrate with respect to x. So now what do you have? You need to integrate this with respect to x. So you have an exponential. الكوساين يطلع مثل ما هو. And when you do this, you will get a cosine between cosine y between 0 and pi. Again, check whether this integrates or not. Check it يا شباب ها. Just for us to see whether I'm doing anything wrong or not. dy equates to 1 or not. Okay. Any question? ناس واحد شيء؟
إذا حصل كالكوليشن بالنسبة للمثال خلي هذا الواي يكون سبعة.
كلام هنا؟
أيوه.
خلاص هنا أصلاً ال fy of y is a function of y. There's no x. شباب, when you find the marginal PDF of y, x disappears. You integrate it with respect to x. خلاص x disappears. And similarly, when you find the PDF of x, you integrate with respect to y. So y disappears at the output. If you still get y here, you did something wrong. If you still get x here, you did something wrong.
What about b?
B is a constant. احنا بنفرض B. B is a constant.
B cosine.
لا, B equals this. This is the value of B. For y, it seems that it cancels. Double check it. Now? It is 1, no? Double check. يعني في هنا steps إنها بس يعني double check. It should give you this answer. Great. Any questions about it? طيب, another example. Find the marginal densities. Now I'm giving you this as the joint PDF. So this is certain function in x and y, ux, uy. What does it mean? It's 0 before x less than 0 and 0 for x for y less than 0. So this is as if I am saying this is equal to x e to minus x y plus 1 for x larger than or equal 0, y larger than or equal 0, and 0 else, right? This is the same, exactly, the first problem. هذه معناها هذه، مرات ممكن أعطيك هذه مرات أعطيك هذه. You should be able to figure out what the state function means. So now, in order to find the marginal densities, again, marginal density for x, you integrate with respect to y. So whatever minus infinity is with respect to y. So simply you write the PDF, the joint PDF, and integrate to y. Now when you replace the u of y, this becomes from 0, right? So when we use the step function in y, the limit becomes 0. Here limit minus infinity, because we are still putting y, u, the step function. Once we remove the step function, the limit should change, because this is not valid for the y less than 0. For y less than 0, what is the value of the PDF? 0. Okay, so don't make this mistake. شباب واضحة الفكرة هنا؟ We change the limit from minus infinity to 0 because there's a step function at y equals 0. Now what do you have? You have here e to minus xy. We are integrating with respect to y, so x is a constant. So this gives you 1 over x, 1 over minus x, right? From y equals 0 to infinity. And you have x here, so they cancel, and you end up with only x. Similarly, if we want to find the PDF of y, we integrate with respect to x. Now the integral here is with respect to x. Again, we write the joint PDF, the integral here from minus infinity to infinity, but now we use this to change the limit. U of x makes that the limit equal 0 because the PDF before x equals 0 equals 0. Now you have what? You have this function integrated with respect to x. So basically this is x e to minus alpha x. This y plus 1 is a constant. So x e to minus x, you need to have integration by part, you do it, and then you end up with basically this is the solution.
Next page, maybe.
Now?
Next page, maybe.
No, here it is. Here, basically the integration by part. These are the two parts, and you end up with this. Now this is called Cauchy square. Cauchy. So the PDF of x is exponential. The PDF of y looks like a Cauchy. Okay, Shwa? Right. Any question? So next time we're talking about conditional distribution of this function. Please, Shwab, make sure that you understand this section. If you don't know the marginal, if you don't know the joint PDX and CDX, you will get confused with the next section. So please try to do it before you come. Thank you very much.